trippers, we've started class. We're going to go over section 9.1. The first homework problem is number 3 that we're going to go over. It says that show that y equals e to the rx is a solution to the differential equation 2y double prime plus y prime minus y equals 0. Well, essentially, in this differential equation, they have told us that what y equals, and we have enough information to figure out what y prime and y double prime equals. Essentially, this is our differential equation right here. Equations that where the correct y value, y prime value, and y double prime value all substitute in and make this statement true, that's what the solutions are. So we have to prove that e to the rx is a solution. To do that, we need to look at y prime and y double prime. Fortunately, they're relatively straightforward to calculate. What am I talking about for y prime? R times e to the rx. So then y double prime? R squared e to the rx. And if I substitute all 3 of these in, I get 2r squared e to the rx plus re to the rx minus e to the rx equals 0. They've asked us what values of r are going to make this statement true. Well, so essentially, we need to solve this then. We need to take this equation right here and solve it for r. To solve it for r, we should see something in common. They all have e to the rx in it, so I'm going to factor out e to the rx, and I'm going to be left with 2r squared plus r minus 1 equals 0. Do we think we can solve this for r? So, e to the rx, can that ever equal 0? I know you make, well, I'll write it for a second. I'll show you what that means in just 1 second. You're going to factor, correct? What does this factor to? 2r. 2r, r, plus 1, minus 1, you can check. That's going to be 2r minus 1r. We factored correctly. So the question is, what are our solutions for r? Can e to the rx ever equal 0? No, you're not going to get any solutions from that. You are going to get 2 solutions here. Those solutions are negative 1 and, well done. Those are the 2 values of r that are going to make the differential equation true. Essentially, if you use the equation y equals e to the, what do we say, 1/2 was the solution? If you use that, its derivative and its second derivative, and substitute it into the differential equation, it's going to subtract out to be 0. Or if you took the equation y equals e to the 2x and substitute this into all 3, its derivative and second derivative in the original equation, substitute them all in, it would also equal out to 0. Does this make sense? Yeah, so far so good. All right. There's a second part to this one. If R2 and if R1 and R2 are the values of R that are found in part A, are 1/2 and negative 1, show that every member of the family of functions y equals a e to the r. So the second part to this question is taking this, which I'm going to copy to a new page. What I wanted. Try that again. Hi guys. Let's try this again. Alright, so here's our differential equation. 2y double prime plus y prime minus y equals 0. They essentially want us to take our 2 solutions from the last problem and prove that y equals a e to the 1/2 was the solution, correct? Plus b, e, and negative 1 was the other solution? they want us to prove that this is also a solution to the differential equation. So how are we going to prove that?
Is this another question or the same one?
It's the same differential equation. You're using a different solution. Well, we don't have all the information we need yet. Right? Do I have all the information I have? So I can't start substituting in yet because I don't have all the information. I got to get y prime and then y double prime. Y prime and y double prime. All right, y prime would be 1/2
a e to the 1/2 x.
Perfect. 1/2 a e to the 1/2 x plus. Well, actually, you could probably change that plus.
Negative b e to the
B e to the negative x. All right, now we need second derivative.
1/4.
1/4.
Don't stop. A e to the 1/2 x
Got it. I'm not gonna keep going.
plus
Plus.
b e to the negative x.
And kids are
That's for
like,
you, Nitsky.
they can't handle the fire.
All right, we're going to substitute all this in. So what it means is now we have to do 2 times y double prime. Y double prime is 1/4 a e to the 1/2 x plus b e to the negative x. That's all Cam's work right there. Plus 1/2 a e to the 1/2 x minus b e to the negative x. And last but not least, minus parentheses. I need the original solution, the original a e to the 1/2 x plus b e to the negative x. We need to prove that all of this is going to equal 0.
Why do you put the original one back in?
Yeah, the original one right here. Okay, so if I'm going to recopy this, now technically I could have put parentheses here, but I didn't need to because it was a plus sign. If you really wanted to, you could. Okay, so 1/2 a e to the 1/2 x, agreed? Just doing distributive property. Plus 2 b e to the negative x. This is going to copy over 1/2 a e to the 1/2 x minus b e to the negative x. Distribute the negative sign. Minus a e to the 1/2 x minus b e to the negative x. We want to prove that's equal to 0. How are we going to do it?
Like terms?
Like terms. If I take 1/2 a e to the 1/2 plus 1/2 a e to the 1/2, that's 1, right? What's going to cancel out with it? There's another like term on the board.
Negative 1. Negative
The 2b e to the negative x.
No. Negative
Cam's got
a
it.
to the 1/2 x. Sorry.
This one. All 3. If you add all 3 of these together, what are you going to get?
0.
0. Cross them all out. They add up to 0. Now, if you take the other 2 terms, all right, 2b e to the negative x, right? This is negative 1b e to the...
So you can 0. Oh.
So did we prove it's a solution?
Oh, that's what I was doing. So I still cancel that.
Save face, Jeff. Save face.
I guess.
And you can go home and show your parents what you do in spots. Look at this.
Where is this on YouTube?
Yeah. Yep.
What's your YouTube?
You
You have to look it up.
It just records the screen. Nothing, no pictures of us. Just our voices. Okay. Any other questions here? Anything else from the homework?
37.
Okay. What can you say about a solution of the differential equation y prime equals negative y squared just by looking at the differential equation? All right. So this is what they want us to look at. Y prime equals negative y squared. All right. This is tricky. It wasn't necessarily intuitive to me. I did look at the answer, and when I saw the answer, I'm like, oh yeah, that doesn't make sense. So what they want you to look at is say, all right, if you take a function and square it, take anything and square it, what are you always going to get?
Positive.
A positive. When you put a negative in front of it, you're always going to get a negative. So do we agree the right side is always negative? All right, well then what does y prime stand for? In terms of a graph.
It's the slope of the
So it's a negative slope.
Downward parabola.
Close. Downward's right. Not parabola though. It's the rate of change always has to be negative.
Yeah.
What does that mean? What's another way to phrase that?
Slope.
Slope. This function, whatever y is, the derivative is always decreasing. All right. So the function. I'm sorry. Not the derivative is always. The function's always decreasing. Y is always decreasing because the derivative is always a negative value. Does that make sense? Y prime is always a negative. And that's what this is saying right here. Anything squared with a negative in front of it means the right hand side is negative. And y prime stands for is it increasing or decreasing? Well, y prime is always negative, so the graph's always decreasing. This is going way back to before integrals. Right? Okay. Second part to that. Verify all the members of 1 over x plus c are solutions to this. So they want you to verify y equals 1 over x plus c. They want you to verify that this is a solution. So to do that, what do we need? Derivative. We need to figure out y prime. How do we find the derivative of this? Easier than that. I think you can do it. I think we can do that's what I was thinking. I'm just going to double check it, make sure that we're right there.
What city are you in right now?
All right. So if you think of this as x plus c to the negative. Oh, we're taking derivatives. We're not taking antiderivatives. Taking derivatives. I know. That's why I was thinking. That's why I did the same. I made the same mistake, Joel. So think of this as x plus c to the negative 1. You need to. Yeah, you can do chain rule, although there's not a lot to the chain rule here. You're taking a flat out derivative, which means a negative goes in front, right? Negative 1 times x plus c to the new exponent. What was it, Jeff? Subtract. Remember, we're taking derivatives now, not antiderivatives. Okay, that's our y prime. Another way to write this: negative 1 over x plus c squared. It should say, people did bring up chain rule. You're correct to say use the chain rule, but what's the derivative of the inside? So that's why we didn't have to use it. We technically used it, but multiplied by 1 didn't change anything. All right, so what we have to now prove is that negative 1 over x plus c squared is equal to 1 over x plus c. Oh, I'm sorry, the opposite of. Let me change this. The opposite of 1 over x plus c all squared. That's substituting in y prime and y into the function. And then this one's more straightforward. You don't really change this side here. If you square both top and bottom, negative 1 over x plus c squared equals negative 1 over x plus c squared.
It's a 15-minute gap.
So this is going to be our homework portion. The second one will be section 9.2 and 9.3. So enjoy your band trip. We will send you more videos shortly.
It's